Right now, WASP-12b is still spiraling into its host star, and NASA has no way to stop it. Every hour it falls a little closer to total annihilation. The brightest minds in planetary science can only watch, and what this planet is doing as it dies is the part they're afraid to say out loud. WASP-12b is a gas giant, roughly twice the size of Jupiter, locked in a death orbit around a star 1,400 light-years away in the constellation Auriga. It was discovered in 2008, and from the moment astronomers first calculated its orbit, they knew something was deeply wrong. This planet completes one full revolution every 26 hours, not 26 days, 26 hours. It skims so close to its star that the surface temperature reaches 2,200 degrees Celsius on the day side. Gravitational tidal forces have stretched and distorted it into the shape of an egg. It is bleeding material into space with every single rotation, the star actively pulling away its outer atmosphere. And that process has not stopped. Not for a single day since we found it. Not once. Here is where it gets impossible. Under everything we know about how planets form, and we have spent decades building that model, a world like WASP-b cannot exist where it is. Gas giants are born in the cold outer edges of solar systems, beyond what astronomers call the frost line, where temperatures are low enough for volatile ices to condense and seed a growing planet. WASP-12b is nowhere near the frost line. It sits deep inside what should be a dead zone for planet formation. The temperatures at that orbital distance would vaporize rock, let alone ice. The standard formation model says this world should never have been born at this location, but it is there. Measurably, undeniably, catastrophically there, and its orbit is decaying. Right now, the orbital period is shrinking by about 29 milliseconds every year. That sounds tiny, but here is the thing, and this is the part that matters over a planetary timescale. That number is a death sentence. The obvious explanation is migration. Maybe WASP-b formed far out and drifted inward over billions of years. Planetary migration happens. We have evidence of it in other systems. But migration theory predicts a planet should stabilize once it reaches a gravitational resonance with its star. WASP-12b never stabilized. It kept going, and it is still going right now. The rate of orbital decay does not match predictions from tidal interaction models. The planet is falling faster than any accepted mechanism can account for. Teams at Caltech and the Harvard-Smithsonian Center for Astrophysics have modeled this system multiple times, adjusted the variables, rerun the tidal dissipation math. And every single time the numbers come out wrong. That is not the part that worries them most, though. Not even close. Here is the strange part, and this is the part they genuinely cannot explain. When researchers used the Hubble Space Telescope to examine WASP-12 in detail, they found something they were not looking for. Two additional stellar objects appear to exist in the vicinity of this system, possibly gravitationally entangled with it. If those companion stars are confirmed, the entire story of how WASP-b ended up where it is changes completely. Because a three-body gravitational interaction, what physicists call the Kozolitov mechanism, can pump up a planet's orbital eccentricity over millions of years, dragging it from a stable outer orbit all the way down into a death spiral. That means WASP-12b may not have drifted inward. It may have been thrown, hurled inward by gravity itself, launched into an inescapable collision course it had no way to avoid. And here is the number that matters. Astronomers estimate that roughly half of all stars in the Milky Way exist in binary or multi-star systems. Half, which means what is happening to WASP-b right now is not a bizarre cosmic exception. It may be one of the most common death sentences in the universe. Planets flung inward, absorbed, erased, and no observer anywhere would know it was coming. That gap between what our models predict and what WASP-12b is actually doing is exposing something uncomfortable. We built our entire understanding of long-term planetary stability on the assumption that gravitational systems behave predictably over billions of years. WASP-b says they do not have to. A hidden companion, a quiet resonance, a slow three-body gravitational pump operating across timescales too long to directly observe, and a planet's entire future can be rerouted without a single warning signal. Astronomers are now going back through the exoplanet catalogs, re-examining systems that appeared stable, searching for companion objects that might be doing quietly to their planets what is already visibly happening to WASP-12b. And what they are finding is making some of them uncomfortable. The number of systems showing unexpected orbital anomalies is higher than the formation models predicted. Significantly higher. WASP-12b will be consumed by its star in roughly 3 million years. On a cosmic scale, that is a blink. The question no one has answered, the one that follows you after you sit with it long enough, is this. How many other planets are already in that spiral right now without anyone knowing? And is there any way to tell the difference between a stable solar system and one that has already been quietly condemned? Tell me what you think in the comments.